Alright guys, we're going to do 3 examples again today, but they're going to be slightly more challenging. So again, I would encourage you to pause the video before I do each solution. Try to do the solution on your own, and then watch the video to make sure that you did it correctly. So again, we're asked to find the most general antiderivatives of these two functions. So starting off with number 1, when I take the antiderivative of 2 cosine of x, hopefully these are starting to get a little easier for you. This is going to be 2 sine of x. That's pretty simple, because the derivative of sine is cosine. This second term here, I would encourage you to think about like this instead. So I'm just going to rewrite this over here as 3 times 1 over the square root of 1 minus x squared. And that should look familiar. So 1 over the square root of 1 minus x squared is the derivative of a function that we're aware of. And we know this just from memorizing some of these general derivatives earlier on in the year. The derivative of inverse sine is that expression. So the antiderivative of 3 over the square root of 1 minus x squared is going to be 3 inverse sine of x. And again, that's because the derivative of 3 inverse sine of x would be 3 times 1 over the square root of 1 minus x squared, which would be this. Right? So we're just recognizing that that's a derivative we're familiar with, and that's why memorizing those inverse trig derivatives was a useful thing earlier on in the year. And if you haven't done that yet, you should go back and memorize those 6 major inverse trig derivatives. So the antiderivative generally of this function is going to be 2 sine of x minus 3 times inverse sine of x plus some constant that we cannot figure out based on the information we've been given. All right, in the second example here, f of x is sine of x over 1 minus sine squared of x. And before we do anything, again, we're going to want to probably recognize one of our trig identities that says that sine squared of x plus cosine squared of x equals 1. And if that's true, then I can subtract sine squared of x from both sides here, and I'll get 1 minus sine squared of x. So what I'm going to do immediately is not take the antiderivative yet, but rewrite this as sine of x over cosine squared of x. The next thing that would be useful to do in this case is to separate this into 2 fractions. So sine of x over cosine squared of x could really be looked at as 1 over cosine of x times sine of x over cosine x. Right? And if I multiplied this, I would end up with this. So these are the same thing, but I could rewrite these as the functions that they actually represent, because we know that 1 over cosine of x is actually secant of x. And sine over cosine is actually tangent of x. So what I've done is just taken this original function and rewritten it like this, and the reason that's useful is because this should ring a bell. There is a function that we're aware of that has this as its derivative. So when I take the antiderivative, I'm going to try to remember what function has the derivative secant of x tangent of x. And that function is secant. So don't forget to add plus a constant there. And hopefully we remember that if you take the derivative just as a check, the derivative with respect to x of secant of x is itself times tangent of x, right? This is just a thing that we've done in the past, and now we're just applying those skills from when we remember doing them the first time. So this is the most general antiderivative there. And right now we can't find the value of c, but now we're going to do an example with an initial condition, so we will be able to find c. So now we're asked to find f, and this is more specific. We need to actually find this function, including the constant value. So we'll take the antiderivative just like we normally would, and then we'll use this initial condition that's been given to find out what that constant would have to be. So we did an example like this in class. I think that first what we should do is rewrite it so that there are 2 fractions here. Okay, so we have x squared over x plus the square root of x over x, which is equal to the original function, but this is going to be an easier way to see things, because now I can rewrite this x squared divided by x is just x. And if I were to look at this as x to the 1/2, then I would have to divide x to the 1/2 by x. And so that's going to be x to the negative 1/2. So now I have this as my original function, this derivative function, which is the same thing as the original function. I haven't taken its antiderivative yet. But now what I'm going to do is take the antiderivative of each of these two terms, and it's going to be a little bit easier to do. So f of x, the first term is going to be a quadratic term, and what would have to be in front here for me to bring down this 2 and end up getting a 1? It would have to be a 1/2. Or I could follow the rule that we came up with in class when we first did this and divide this whole thing by 2 so that that 2 cancels and I end up with a 1. So that works. Over here, negative 1/2 plus 1 is positive 1/2. And again, I'm going to want that to cancel, so I'm going to have to put a 1/2 in the denominator. All right, so let me just rewrite this, and don't forget that there is a plus c. So f of x equals x squared with a 1/2 in front plus, and remember when we divide by 1/2, that's the same thing as multiplying by 2, plus c. Okay, and so now what we know, based on our initial condition, is that f of 1 is equal to three, because that was given to us to help us find this constant value. And now I can go through the process of solving this. It's lucky that we've been given an initial condition with a value that's so easy to work with, because 1 to any power is itself. So 1 squared times 1/2 is going to be 1/2, plus this is going to turn out to be 2, plus c equals 3. All right, so I'm going to want to subtract the 2 and 1/2 from the other side, and I'm going to end up with c equals just 1/2, right? Because if I do 3 minus 2, I'll get 1, and then 1 minus 1/2 is 1/2, so c must be 1/2. And so then our final answer here is that f of x has to equal 1/2 x squared plus 2x to the 1/2, and you could write that in radical notation if you'd rather, plus 1/2. All right, a couple more examples. Tomorrow we'll do some more challenging examples, and then on Friday we will get to some new content again. But we've been sort of taking it slow with this unit, and hopefully your other teachers have been as well. And so tonight what I'm going to ask you to do is to fill out a Google form to kind of gauge how things have been going so far and see if we need to make any adjustments moving forward.